So testing applications is something that usually gets overlooked, especially by junior developers, but it is an essential skill that you'll need for the workplace. So in this tutorial, we're going to take a brief introductory look at the React testing library and how you can use it to test a simple React app, including following the arrange, act and assert convention of putting your tests together. So we're going to create an app really quickly, but feel free to skip to the testing if that's what you're here for. But let's dive in and start looking at how you use the React testing library to test React apps. Okay, so to start learning about testing with React, I've got a sample create React app template just set up here. It's with using TypeScript, but the same sort of thing that we're going to be doing applies to JavaScript as well. And I'm first of all just going to show you a little bit about the testing in React, and then we'll build out the bug tracking app and then come back and layer on some specific tests for that application towards the end of the tutorial. So with the create React app template that we've got set up, we actually have a test file set up here, a spec file. And inside the spec file is one test. Now, to run these tests with create React app, there is a script already set up, and we simply say npm run test. And you should see that that actually brings up the Jest test runner. And just to run all tests, if we just tap A on the keyboard there, you'll see there's one test set up, which is denoted by this test block, and you can see it's currently passing. So what's this test actually doing? Well, it's rendering the complete app using the app component, and then it's looking for some text on the screen saying learn React, and this is a regular expression, so it's looking for this text in a case insensitive manner, and it's just basically expecting that that element that contains that text will be in the document. And you can see that there because we've got this link tag down here that says learn React. So for example, if we were to change this to something else, so learn JavaScript or something like that, when the tests rerun, when the application's been reloaded, you can see that that's now failing. If we just open this up just a little bit here, you can see it gives us an error saying that we can't find that particular element because this no longer matches. Okay, so that's just a bit of an overview of how to set up and run tests with React. And we're going to be coming back to this test in just a moment, but let's make a start on actually creating our bug tracking app so that we can make some more specific tests. So let's head on over to the app.tsx file, and just for starters, I'm just going to remove a lot of the stuff that we've got in here to get us back to a starting point. And let's just put a heading level 1 tag back in here, and let's say bug tracker with a little bug emoji, and save that. And you can see that every time I'm saving any of the files, because we've got Jest running, it's actually rerunning all of the tests, just that single one at the moment, and it's each time it's failing. So we can keep that running all the time just to keep an eye on anything that's been changed in our code and whether it's making our tests pass or fail. So we can go back and make that test pass now, because we've got a proper heading for our application now. So instead of learn JavaScript, let's just look for the text of bug tracker on the page. And you can see now that's passing. So this test, all it's doing really is just to say that there's the bug tracker text on the page and that it's in the document somewhere. So we could also update the description here, which you put inside of this test block. So you could say something like it should render the title. And now you can see in the output from Jest, that test is a bit more meaningful, and it's basically just the text that we typed up in here. Okay, so we're going to flesh out the rest of this bug tracking application. It's going to be really simple and not fully featured, but it should give you an idea of how to get started with writing tests. And I'll run through this really quickly because the point of the tutorial is more to look at the tests of React components and React applications, rather than creating a fully functioning app. So if you want to skip to the testing part, then just use the links in the description below. Okay, so let's go back over to the app.tsx file, and what I'm going to do to start off with is create a bit of state. So I'm going to use the use state hooks, so new bug description, and set new bug description. Okay, so this is going to basically be for a form that we're going to use to add new bugs to our list of bugs for our tracker. So it will be the use state hook, which is a string. Just make sure we've got that imported. And we'll initialize that with an empty string there. Okay, so very similar thing here as well. We'll have a new bug priority. and set new bug priority. And again, this is using the useState hook, which will just have a string in there again. And I'm actually going to default this to a priority of medium. And then finally, we're going to create the state that will hold the bug list, the list of bugs, and have its corresponding setter here. And again, that will be useState. And what I probably should have done first here, just to explain what's going on, but I'm going to create an interface in TypeScript here to describe the bugs, the type of bugs that we're going to be storing in this state. So let me just create a new file here. Now I'll call it ibug.ts. And we're going to export an interface here. And the interface will be ibug. And there's going to be a few bits of information for each bug that we're listing. So it'll have an ID, which will be a string, so that'll be handy when we're actually trying to remove it from the list later on. And we'll also have a description, which again is just a string. And we'll also have a priority. And what I will do for that is just create an enum for it in TypeScript here. So we'll say bug priority is the enum. And the different types, let's say we've got low, which is equal to the string of low. And we've got medium, which is equal to medium. And then finally we'll have high, which is equal to the string of high. So the priority now is a representation of that enum. So this is going to be describing the data that we're going to be storing in our state inside our app. Okay, so let's go back to app.tsx. And we're going to be having in here an array of those iBugs. Let's just make sure we import that. Okay, and I'm just going to stub out a couple of functions which we're going to need. So we'll have an add bug function, which will be called when the user's filled out the form and they want to add a new bug to the list. And we'll also have a delete bug action. So when the user is marking a bug as resolved, this will just remove it from the list. Okay, and I think that's all we need at the moment. So let's actually go ahead and create the form to create the bugs. Okay, so let's have a form here. And what we'll do is when that is submitted, we're going to call the add bug function. I have a label here for the new bug description. So this is going to be the information about the bug that the user's typing in. So new bug description is the text in the label, and then we're going to have an input in here which will just be a string, and don't forget the ID for it. And when the value for that changes, I'll just inline the actual function here. So we're going to get the event object, and we will call the set new bug description, and we'll set that to event.target.value, which is essentially the value that's stored inside of the input box itself. And we also want to bind the value from our new bug description as well. So let's just put that in there as well. New bug description. So if we save that now, we should find we've got an input box that allows us to type in there, and that's updating the state that's stored up here in the new bug description state that we created. Okay, so we can pretty much do a similar thing for the priority. So we're going to use a select box for that. So new bug priority. Okay, and we'll just say new bug priority for the label. Okay, and as I say, we're going to be using a select box here. Okay, so let's make sure we've got the right ID for it here, and we're going to do a similar thing here. We'll set the value to be bound to the new bug priority state within the app component. When the value changes in there as well, we get the event object, and we're just going to inline again as we did above to set the new bug priority to the event.target.value. There we go. And let's just put some options in there that match the bug priority enum that we created. So first of all, we've got low and display low, and we've also got the medium priority, and then finally high. Okay, so that's now in there as well. It's defaulting to medium because that's the default that we put in the use state hook up here. And the final thing we're going to need to have is a button to actually submit the form. So we've got button, and let's just set its type here, to be submit, and we'll say add new bug is the title of the button. Okay, so let's fill out these two functions that we've got up here as well. So for the add bug, that's when we actually submit the form. So it's a form event that's coming through to that function. So first thing we want to do is just prevent the default action from occurring. And with that done, let's construct a new bug object. So let's type it to be of type interface of iBug. And for the ID, you can create a random number, or you could just invent something here, but it needs to be unique so that we can find these bugs later on if we need to remove them from our state. So I've actually included the UUID package within this repository, but if you haven't cloned the repository, then you can just install this using npm. So it's just npm install UUID and then import it like so. And that gives us a function UUID to generate a new UUID for the bug. Okay, so the rest of the bug, we need to know the description. So we can take that from the new bug description state that's in the app. And then also the priority is the same as well. And what we need to do here is take the new bug priority that's stored as our state, but you'll see TypeScript's giving us a little bit of an error because we're actually passing it a string, when in reality it needs an instance of this enum. So there's two things we could do here. We could actually change the type of state that's being stored to use the enum, or we could just cast it here because ultimately the enum is just a string. So we'll say it's as bug priority. Okay, so with the new bug constructed, we can update the bug list state in the app. So set bug list. We're going to set it to a new array, and we'll pass in the old bug list so that we keep the existing ones, and then just also pass in the new bug object that we created above here. There's also a couple of things to do here in terms of resetting the form. So we'll set the new bug description to be an empty string, and then we'll reset the bug description priority as medium. So we won't be able to see that state at the moment because we're not doing anything with it, but if we do type something in here and set it to high and click add, we should find that the bug description and priority are reset. So we're pretty confident that this bug list is updated with the new bug that we created. And we'll start using this bug data in just a second when we render a table of all the bugs, but let's just go and finish this delete bug function here. So this will be called from wherever our table is rendered. So we're going to accept an ID, which is of type string in here. And all we're going to do is take the existing bugs that we've got and store that into a new variable. So take the bug list, but we're going to filter it for each of those bugs inside of there and say only keep it in the array if the bug ID does not equal the ID that's been passed into this delete bug function, which basically will remove this particular bug that matches that ID. And all we need to do then is set the bug list to equal to the updated bugs that we've created. Okay, so let's actually now render out all of the bugs in a table. And to do that, I'm going to create a new component, and I'll just call it bug list table.tsx. So let's just set up the component itself here. So bug table, oh no, what did I call it? Bug list table, that's probably about the right thing for it. And just export that as a default from this file. Okay, so there's some props that we're going to need for this. The first thing is we're going to need the actual bugs themselves, and we can type that with an array of iBugs. And we'll also have a prop here called onDeleteBug, which will be a function, and essentially this will call the function that we created in the parent app to update the state when a button is pressed to actually remove the bug. So let's first of all get that props from the params that have been passed in there. So we've got onDeleteBug equals props, and I'll create a function here. So when the resolved button is pressed, ID string, we just want to call that onDeleteBug function and pass it back the ID, which will call that function in app.tsx to filter out the bug based on this ID. Okay, so let's crack on with rendering the bugs in a table here. So just going to return a table element here. and in there we'll have some headings, so description, and we'll also have the priority. And I'm just going to leave an empty column on the end there for presentation purposes for the resolve button that we're going to add. So inside the body, a couple of things here. First of all, we're going to check the bugs that have been passed in as a prop. And if the length of that array that's passed in is 0, then we'll just render a single row and that just basically says no bugs found. But if not, if the are some bugs, so if bugs length is bigger than 0, then what we want to do is for each of the bugs in the array, we'll say bug is equal to a table row, and let's pass that a key as well so we don't get any errors in our console. So bug.id, again that should be unique for each of those, so that's a good candidate for the key there. And we're going to have the 3 columns filled out here. So first of all we've got bug description, and then we want, we'll just close that off there, and then we want bug dot priority, and then the final cell in the row will be actually a button, and the on click event for that is just going to reference the resolved pressed function that we created above, and we just pass in the ID of the particular bug, so for which this has been pressed, and then the text inside of the button will just say resolved. Okay, so that's pretty much it for the markup for the table. Let's go back to the app.tsx file and add that in here. So down here we want the, let's put it above the form, that makes sense to put it there. So we'll import the bug list table here and pass it in as its props, the bugs. So in the app component, the bug list is basically stored in this bug list state, so we'll pass the lot into that table there. And then we've got this function as well that we're passing in on delete bug. So when that occurs, we'll basically get a function back that provides us with a string, and then we can just literally call the delete bug function that we created here with that ID. So if we save that now, we haven't closed off that component, so let's just close the tag there. Okay, so we've got our table appearing here now, and we should be able to press the resolve button to remove the bug from the table. So now we've got no bugs found. So let's just try and add in a new one. Let's say it's high priority. And you can see that bug's been added to the table via the list of bugs that we've passed in to its props. So obviously this doesn't look great. Let's add some CSS before we start working on our tests. So let's remove everything from the placeholder in app.tsx. So for the table, let's just put a border around that, so 1 pixel solid, and make sure the width of the table is 100%. And the table for each of the cells and also each of the heading elements in there, let's just make sure the text is aligned to the left, and also put a bit of padding inside that just to space things out. And for the table headings, let's just set the background color to be something like azure, just to give it a bit of style around there. So for the actual app, let's create a class, and we'll just set the width to be a maximum of 600 pixels, and also margin 0 and auto just to center it. And let's create some classes down here for the new bug form. So app.new bug form. So again, let's make sure the width of that is 100%. I'm going to set it to display as flex, but a flex column. The background color, we'll use that azure color again. Padding 10 pixels to give it some spacing, and we'll also put a border around that as well, solid black. And let's just move it down a little bit from the list of bugs as well by 20 pixels. And then also for the new bug form, I want to target every element inside of there and just actually put a bit of margin on the top and bottom just to space things out a bit. And then for the add new bug form input and also the add new bug form select box, let's just give some standard padding for that, so 10 pixels say. And then finally for the add new bug form button, let's set the background color to something different. Let's use cadet blue, and then remove its border Again, padding 10 pixels, and then the color is white for the text. Okie so we just need to add those classes obviously to our app, otherwise nothing will display. None of those styles will be rendered. So our class name is app for the main app. And then for the form, we'll give that a class name of add new bug form. It doesn't seem to have applied things correctly there, so let's have a look in the CSS. Okay, so I'll put app new bug form instead of add new bug form there, so let's just change that. Okay, and that's rendering a bit more like I was expecting it to see it. Okay, so just some basic styling so that the app doesn't look terrible. And we've pretty much got a reasonably functioning form here at the moment. Obviously there's a few problems. We can add new bugs without adding a description and so forth, but we don't need to worry about that for what we're going to be doing with our testing. So let's just test this out one last time. A bug in the CSS, for example, which is high priority. Let's add that bug in and let's just resolve the other one that we've got in there. Yep, so that's all working fine. Okay, so now we're going to move on to the testing of our bug tracking app. So this is the point of the tutorial really, and we're going to look at how you can use the React testing library to write some tests that's going to test some of the functionality that we've implemented in this simple bug tracker app. So we're going to start at the component level here of the bug table. So the job of this component is basically just to render the bugs, the data that's passed into it. So we're going to write a few tests that will provide it with some dummy data to the component and see if it renders as we expect it to. So you'll see how we can render a component in our test and make sure that it's appearing as we expect it to. So I'm going to create a new file for this. So over here in Visual Studio Code, let's create a new file. So we'll match the name of the component file. So we'll say buglist_table.spec.tsx. And the first thing we need to do is import some of the functions from the React testing library. So let's start with there. We want to import this render function, and also there's a function in there called fire event. And importantly as well, we want this screen function as well. Okay, so you saw towards the start of the tutorial that we created a test using the test function, and you don't need to import that. It will be automatically included when you're running your spec files here. And just as a note as well, you might notice that because we've got no tests inside of this particular file at the moment, we're actually getting an error, and Jest is just complaining that our test suite must have at least one test. So that should hopefully disappear in just a moment. So let's create a new test here. And the test I'm going to do is going to say the bug table should display a list of bugs. So that's the primary purpose of this component, and what we're expecting is that if we pass in a list of bugs that have the iBug interface, then the bug list table component should be able to render them on the page. So what we need to do for this test is we actually need to have some dummy data to pass into it. So I'm going to create a new variable here called bug list, and I'll make sure it matches the iBug interface. So it's going to be an array, and I don't need to worry too much about the actual IDs here at the moment. So I'm just going to use 1, 2, 3, 4 for the idea of this one. And I'm going to create a description for this bug that just says a test bug. And I will also set the priority for bug priority to be low. It's not too important for the test here. Let me just close this down so you can see the entirety of the window there. And let's create a couple more here. So let's just update the IDs for them. And let's say another test bug and one more test bug. And let's just change this middle bug's priority to medium. Okay, so we've got some dummy data here. What we actually need to do is render the bug list table component and pass that dummy data into it and then see what happens by examining the component that's been rendered. So luckily we don't need to actually look at things in the browser here. This is all done within our test file, but we call the render function to actually render a component. So I'm going to render the bug list table component. And if you remember, we need to pass in a couple of props to that. We need to pass in the bugs. So I'm just going to pass in that bug list array that I created. But I also need to pass in something for the onDeleteBug prop. But because we're not actually testing that in this particular test case, what I'm going to do is just pass in an empty function, just so we don't get any errors within our TypeScript. Okay, so for this test now, that will actually render that bug list component with all of the bugs. We don't need to do anything else with the component. We don't need to press any buttons or anything like that. It should just render those bugs for us automatically. So we just need to make some assertions now to make sure that the component has been rendered correctly. So the way we're going to do that in this instance is we're going to create a new variable called rows, and we're going to access the screen object that we imported a moment ago. And there are lots of different methods in here that will allow you to get elements from your component and then make some assertions about them. So I'm actually going to use the getAllByRole method here. And I'm going to say I'm going to get all of the rows from the table that's been generated. When you're probably thinking, well, you didn't actually add any elements on the page that had the role of row, so having like an array or attribute or something similar. And you're absolutely right, but the rows that we've put into our table will automatically have this particular role. So this will actually return all of the rows, including the header, in fact, of the table that we created. And I'm going to show you in a minute how you can get an element in a more specific way. But for this test, you can see that you can use the role of an element on a page to actually get it using this screen object. So the rows variable should now hold all of those rows. What I'm going to do is actually loop through all of the rows apart from the header row, and then just check that it actually matches the text that we've got in our description in each of our bugs up here. So I'm just going to use a for loop for that. So I'm going to say let the index to be 1, which will skip out the header row, and then for the index keep going until the length of rows has been reached, and for each iteration we're just going to increment index by 1. And to make an assertion, we use this expect function. So we're going to say for each of the rows that we've retrieved by its index, we're expecting it to have the text content of the bug list array items, and I'm just going to subtract 1 from that index x. We're starting at 1, but obviously the array will start at 0 here, and then just get its description. So for each of the rows on the page, we should have the text content for each of these bugs up here. Okay, so you can see we've got the tests passing here. Just to show you why we started the index at 1, if I actually save that with the index set as 0, and just remove the subtraction of 1 here as well. So you'll see here we're saying we're expecting the element to have the text content a test bug. So that's this value that's coming back from here. But because the first row that's retrieved in this rows array will be the header, you can see we've got description and priority, which is obviously what we've got stored in the rows up here. So just to let you know, that's why we modified the index values like that. So there are some other approaches that we could do to achieve the same result, and I'll show you that when we're testing the other parts of the app in just a moment. But let's just finish off the bug list table. So the other key thing with the bug list table is that we've got this button. So we want to actually test when we click this button, is it actually going to remove the bug from the array? So let's create a test for that. So we'll say test the resolved button should remove the bug. So the setup of our app here presents us with a bit of a problem, because when we actually click that button, the component itself, the bug list table, isn't actually handling any of the filtering of the state. It's actually passed up to the parent component to do this. So it kind of blurs the lines a little bit about if you're actually testing the bug list table or if you're testing something outside it. I think it's always best to try and test things in isolation. So what we're going to do is we're going to create our own onDelete function and then pass that into the rendered component within our test. And we'll just test that that button is actually calling that function, but we'll also check that the bug list that's passed in as a prop is also updated. Okay, so I need this stubbed data again here as well. So I'm going to put the bug list in here again. I'm just going to set it as a let when I'm declaring the actual variable there, because we're going to be reassigning a value to it in a moment. Okay, and what we'll do is we'll just create a similar function that we had in the app. We'll just say remove bug by ID. I'll say is a string that's passed in there. And we'll just say for the bug list, which is this variable up here, we'll just say the bug list is equal to the bug list filter, and it's exactly the same code as we had in the app. Bug.id does not equal ID. So now when we're actually rendering the bug table component, let's say render, and we're going to render bug list table, and the bugs is equal to, again, the bug list. But this time, the onDelete bug, we can actually pass that in the function that we've created above here. So we know the bug list table will provide us with this ID when the button is pressed, and we'll just call the function here. So remove bug with the ID value. Okay, so what we're going to do now is we're going to use the fire event object that we imported from the React testing library earlier on. And we're going to call a click function on there. And we're going to click the resolve button, or at least the first one that's presented in the bug list table. So to do that, we can use the screen object. And this time we're going to say get all by text. And we're going to get any element that matches the resolved text here. As I mentioned, there are lots of these different queries that you can use to find elements within your components. And of course, we only want to click the first button that we find. So we're going to get all of the elements, but then just filter it out to the first one. But this gives you the option to choose a different button if you wish. So the first thing we're going to do is say get all the rows again. And we're going to say screen.getAllByRole. And it's get all the rows. And we're going to make an expectation here that the rows.length is going to be 3. And we should expect it to be 3 because don't forget we've got the header row at the top of the table. So when we run the tests now, we actually get a problem here because we're actually getting a result of 4. So there's 4 rows there still when we're expecting there to be 3 rows. So clicking the resolve button has actually caused the function to run. But what we need to do when we're rendering our components within our specs is actually re-render them if we make any changes, such as we have here. So we can do that quite easily. We can actually extract a function called re-render from the call to render. And if we just copy this code here again, once we've actually clicked the button here, what we can do is instead of rendering the component again, we can re-render it because at this point the bug list array will have been updated. And if we save that, oh, and we're actually getting an error. I wasn't expecting that. It should have only 3 rows there. So let's have a look. We're re-rendering the component with the new bug list, and the remove bug function should have been called. Okay, so I think I've got a space here in between the does not equal ID, so it would have been matching more than that one element. Okay, so just adjusting that, you can see the test is now passing. So there you go, we've got a tested bug list table component now. There are some more tests that we can add in the app. For example, we haven't tested what happens with the form here. So let's open up our app.test.tsx file. And we're going to create a new test here for creating a new bug. So we'll say it creates a new bug for the name of the test. And hopefully by now we've got some knowledge about how we can actually render a component and interact with the component and then test to see what it displays. So the first thing we're going to do is we're going to actually render the app component because that's what we're testing here at the moment really. And now I want to get the actual input element here to actually type something into it so that I can see what I type into the input element actually ends up on the bug tracker itself. So as we mentioned, there's quite a few different ways that you can query the component that you're working with. So to get that input element, we could, on the screen object, actually use the getByTestID function, and that allows us to get an element on the page that has a specific data attribute. So we obviously need to go and add those attributes in first, so let's go over here into the app.tsx and find the input element that for the new bug description. And the data attribute I'm going to add on there is just data test ID, and I'll say it's new bug description. Okay, and if we save that and go back over to the spec file, now we can just get the elements by that specific unique identifier, and we know exactly which element we're going to get returned here. So that's really useful because we can target that one specific input element directly. And unfortunately on the fire event object, there isn't actually a type function that we can call directly, but there is another object that we can import, which is called user event. which you can see is just found in the testing library user event package. And on that user event object, we do have a ability to type into an input field. So we just need to specify the input field that we want to type into. So here's our input element here. And then just what are we going to type in there? Well, I'm just going to pass it a string, just saying testbug123. And I'm going to leave the priority as it is, but you can do the same sort of thing for that. But now I want to click the add new bug button. So I'm going to do the same thing again. I'm going to go back over to the app.tsx file, find the button, add a data test ID attribute to it, and I'll just say add button is the ID. And back in the spec, don't forget to click something within your component, use the fire event object, and then the click function that's found inside there. So how do we find the button? Well, we do exactly the same thing that we did here to get the input element by test ID. So screen.get by test ID, and then pass it in that add btn identifier that we gave it. So we've arranged our test by rendering the app component, then we've made some actions by typing into the input box and clicking the button. Now we need to make some assertions as to what should have happened. So at a very high level, we can just test that the testbug123 text has been rendered on the page somewhere. So if, for example, I could say expect screen.getByText, and again, similar to how we did in the app to start off with, we could either use a string or a regular expression. So let's just say testbug123 should be in there somewhere, and make it case insensitive. And with the expectation, we're just saying it should be in the document. Just to prove a point, if I just remove the 123 from there, that string will no longer match and we'll actually get an error. And quite handily with the React testing library, it actually shows you what has been rendered for the app component, which makes debugging the code and working out why your test failed a lot easier. So that pretty much wraps up our introduction into React testing with the React testing library. So hopefully you've seen how you can use the testing library to first of all render a component and then interact with that component using the fire event or user event objects. And then finally, using the expect function, you can make some assertions about what's happened to the component by checking for the existence of certain things on the page. I should say this is just an introduction to testing as well. There's lots more things that you can do, but at a very simple level, hopefully this will get you started to start writing some tests for your projects and your apps that you're creating. So that's it for this tutorial. Just before you go, don't forget to subscribe to support the channel and so you don't miss out on any future tutorials, and I'll see you next time.